So in class today, we're doing covalent bonding, which is the sharing of electrons between two or more atoms of similar and high ionization energies. So we're dealing primarily then with nonmetals, thing on the right side of the periodic table. So we're going to go ahead and just do a couple examples of how to draw those. So first off, let's go with the formula for the number of bonds, or number of covalent bonds. So number of covalent bonds. Okay, so we know that electrons are the things that do the bonding. So first off, we say number of octet electrons. Okay, so the amount of electrons that it needs to bond. It needs 8 valence. 2 are from the S subshell and 6 are from the P subshell. And we subtract that from the number of electrons it actually has available to bond. So we say number of valence electrons. And that's going to give us a number, right? So that's going to give us the total number of electrons available to bond. But we know that a covalent bond is 2 electrons. So what we're going to do is go ahead and divide this number by 2, and that will give us the total number of bonds. We then simply go around and give everybody their bonds. Remember, though, that hydrogen is an exception. It only wants 2 electrons or 1 bond. Boron is an exception. It only wants 6 electrons or 3 bonds. So let's go ahead and do an example. Do a super simple one first. Let's go ahead and just do oxygen, O2. So I'm going to go line it up first. So total number of octet electrons. Well, there's no exception in oxygen, so that's going to be 8 times 2. So that's going to be 16 octet electrons, minus valence electrons. Well, we know that each oxygen has 6 valence electrons, or 6 Lewis dots, so that's 6 times 2 is 12. Now, this allows us to have 4 leftover electrons, but they're locked up in covalent bonds. So we have 2 bonds, 2 covalent bonds. So what do we do with that information? Well, the first thing we do is we put the oxygen atoms next to each other and we give them the 2 bonds. And then we make sure that everybody has their octet of electrons. So let's start with the oxygen here on the right. 2, 4, 6, 8. 2 lone pairs and 2 covalent bonds. Now let's do this one. 2, 4, because they're being shared. 6, 8. And that's the Lewis structure for oxygen. Let's go ahead and do something a little bit more complex. Not really that complex. CO2. Okay. So CO2, octet electrons. 3 atoms, all needing 8, so that's 24 octet electrons. Minus valence. So we know that carbon always wants 4, and we know that oxygen always wants 6, and there's 2 of those. So 6 times 2 is 12, plus 4 is going to be 16. 16 divided by 2. So 24 minus 16 is 8, divided by 2 is 4 bonds. Okay. In a situation like this, we have to decide who goes in the middle. And if you look here, you see that, Max, there's also a bunch of stuff over there. So you know, a bunch of stuff. That's all kind of like garbage stuff from Exploratory. So if you notice here that carbon has the most lone electrons, carbon thus has the most bonding power, and we're going to put carbon in the middle, oxygen's on the right side. We got 4 bonds, 1, 2, 3, 4. Let's give everybody their octet. Start over here on the right side. 2, 4, 6, 8. That oxygen atom has its octet. See? 2, 4, 6, 8. Go to this carbon atom. 2, 4, 6, 8. That carbon atom has its octet. What about this oxygen atom? 2, 4, 6, 8. Good there. Let's do one more and we'll be done. How about a PCl3? Okay, so octet electrons. We have 4 atoms times 8, 32. Valence electrons. P has 5 valence, and chlorine we know has 7, 2 in the S, 5 in the P. With phosphorus, 2 are in the S and 3 are in the P. And this 7 is times 3, that's 21, plus 5, that's 26. Okay, 32 minus 26 is 6, divided by 2, 3 bonds. Who here has the most bonding power? That's going to be phosphorus, because it has the most lone electrons. Put that in the middle, put Cl around the outside. Give 3 bonds, 1, 2, 3. Now let's go around and give everybody their octet. Cl has 2, 4, 6, 8. Good to go. Chlorine, 2, 4, 6, 8. This chlorine, 2, because we share that, 4, 6, 8. And phosphorus gets those as well because they're shared, 2, 4, 6, and 8.